Hi there. I'd like to introduce the concept of the HoleWizard. So what we're looking at here is a particular part, and there is a note here that's indicating that there are going to be 4 holes here, and that those holes are going to be tapped holes, so holes with threads, and the call out is M12, so a metric 12 millimeter screw with a 1.5 millimeter thread, and the depth of the hole is that the hole depth itself, which actually refers to from the top of the hole to the bottom of the main hole itself, should be 31.5 millimeters, and then the thread depth would be 24 millimeters. And you'll note that there is a angled edge here because the assumption is that that hole is being drilled with an actual drill bit. And that is then, the tap is then utilized, and the full tap of the full threads will only go down through a certain amount here. So let me show you how we put that in. We'll come to our part, and up here under the Features tab is the HoleWizard. So there is an actual icon for it. So we'll click under the HoleWizard and let it launch that tool. And we have 2 tabs here, the type of hole and the position of the hole. So the type of hole, we can hover over these. There's counter bores, countersink holes, and just plain holes. And this is the one that we're going to be using now. This is going to be a straight tap. So I'll highlight that one, and I'm going to reset the last time I used this, I was using custom sizing. So we're going to use ANSI metric. There are all different types of screws. Some of these are proprietary, something called helicoil, and progressive and superior. Those are specific hole types. ISO is the European Union, and then there are some separate ones. But we're just going to use the ANSI metric, and I want a straight tapped hole, not a pipe tapped hole. Pipe tap holes that are tapped for pipe fittings are tapered. We want just a tapped hole, and then we'll go down to the hole specification. It was M12 by 1.5, so a 12 millimeter nominal diameter hole with a pitch of 1.5, and we are going to do an end condition, which is blind, and I can turn off the show custom sizing. I don't necessarily want to show any custom sizing here. And the depth of the hole was going to be 31.5 with a thread depth of 24 millimeters, so that's what I'm showing here. Notice that there's 2 variants for the hole depth. We're doing it from the full hole depth, and the thread depth is blind, which will be 24 millimeters. There are some additional options here. The thread call out is the way we want, so when we are doing a machine drawing, it'll automatically provide that information for us. And we do not want to have the near side countersink turned on. That would create a little bit of a chamfer at the top of the hole, and that's not what I want in this particular situation. So in all of this, I've now chosen the hole type, the standard, the type of hole again, the size of the hole, and its depth. So I've completely done all the type. I'll switch over to the Positions tab, and it says select the face for the hole or slot. So the hole face is going to go here, and now it turns into a sketch tool, which I could start doing some sketches, or in this case, I'm just going to hover over the edge of the circle and find that I just want the center of the circle. So I'll click there, and it has created the hole. And if there were multiple locations where I wanted to do that, I could continue and I could put more holes down. But that's all I need. I've specified the type and the position. I'll say OK. And SolidWorks creates the hole. And you'll note that the tapped hole contains a number of sketches and sketches for the whole thread itself. If I went to a section view here and did a side view here, I can push back and we can see that the type of hole that has been created. If I do this front view, and you can see that the edge of the bottom of the hole has that angle, assuming it was done with a standard drill bit, and this dotted line shows you the location of where the threaded holes are going to be. Okay, so that is how to create your basic hole, and let's switch to another example now. Okay, this is the next example we're going to look at. So this part has two countersink holes, and it's called out, there's two of them. It's a 0.26 inch through hole, and the countersink is said that it's a 1/2 inch by 100 degrees. I have a little graphic here showing what that means. So the total diameter of the outer ring of the countersink is going to be 1/2 inch, and the angle is 100 degrees, which is the whole angle. And the location is on the center line at a distance of 1.25 inches. So let's go into SolidWorks, and we see we have the part partially made here. And what I'm going to do is I'm going to create a sketch that's just going to give me the location where the hole needs to go. So I'm going to create a sketch, and I'll say it on this face. I'm going to use a center line. So catch the midpoint there, make sure I'm horizontal, and I'll put the dimension on and set that to being 1.25. Okay, and that's all I need. I'm just going to end the sketch here. So what I now have created is a location on this face where there's a point that I'm going to be able to put in the hole. So now I'll go to the Features tab. I'm going to go to the HoleWizard. And for this hole type, I want to use a countersink. And I'll set the standard to be inches so that all my units will be in inches. And the hole specification, I can, since I don't know what size screw it is, it's saying 0.26 through all, and it's giving me the actual dimensions of the hole. That's what I'm going to do here. So I'm going to do show custom sizing, and the hole is 0.26. That's the through diameter. The outer diameter of the hole itself is 0.5, and the angle for the hole is going to be 100 degrees. I will then go through, the end condition is going to be through all, and that gives me all the information I need. So it's a countersink hole, the units are inches, and I'm using custom sizing for the hole itself. I'll now go to my Positions tab. Wait for it to wake up. I'll select this as the face. and then I'll just come over and click on that point that I had created, and we say OK, and we have the custom sliced hole as the custom hole that we've created here. And again, I can just do a section view here just to pull the high piece out here. And we can see that that is indeed the type of hole that we wanted. Okay, and we'll do one more example here, one with a counter bore. So let me pull that up. Okay, for this part here, we're using the HoleWizard to do three things. There is a countersunk hole here, there is a threaded hole here, and this big cutout here is actually given to us in terms of a counter bored hole. So I can use the HoleWizard for all three of these situations. So let me just bring this in here and use my zoom tool here. Bear with me for a second here. And zoom in here. So the first thing I'm going to do is I'll put in this counter bore hole. And in this case, we're going to use some custom sizing. So let me come over here. I'll go to the HoleWizard. I'm going to use a counter bore now. I'm going to reset the custom sizing. I'm in the inch mode here, so I'll go ANSI inch. And I don't really care about the type of screw right here, so I'm not going to bother changing that. I'm just going to go to custom sizing, and the through hole is 0.65. The diameter of the outer bore is 1.38. The depth of that bore is 0.45. And the end condition is through all. We're going to have a near side countersink on it, and the outer diameter of that is going to be 1.43, which is what we have, and the angle is going to be 100 degrees. So that are the specifications for what I want for the hole. I'll now select for positions. I'll select the top face, and the center point is already there, so I'll select OK, and I'll click OK, and we can see that we have the hole size went in here, and there's also this near side countersink, this fillet or chamfer on the outer edge that we did. Okay, so now we're going to do one more. We'll do this one. So we'll go to the HoleWizard again. In this case, it's going to be a countersink. I'll reset the custom sizing. In this case, the through hole is 0.26. The outer diameter is 0.51. The angle is 100 degrees. The end condition is going to be through all. We're turning off. There's no countersinks on it. And I'm going to go to my positions here, select this face. I'll hover over here to wake up this point, and I'll hover over here to wake up that point. All right, and then the last thing, I want a 1032 tapped hole, and it's going to go through all, but not through the entire thing. So what I'm going to do is I'm going to make a sketch on the front plane. The height of this hole is, let's see it over here, it is 0.5 inches. So I'll use a center line select the bottom, just pull the line up, use a smart dimension tool, and set that to being 0.5. And I'll go ahead and just close this sketch. So now all I have is that the hole there. I'm going to turn on the visibility of the front plane so I can see it. And I need to turn on the visibility of planes. View planes. That should be turned on. Why didn't I turn that on? Oh, I want to show it. Never mind. I want to exit out of there. I created a sketch instead of turning on the visibility of the plane. Sorry about that. So I'm going to go again to the HoleWizard. In this case, it's just a tapped hole. I'll reset the custom sizing. As a matter of fact, I'm not even going to turn on the custom sizing. I'll turn that off. I want it to be a tapped hole, and the size is going to be 1032. So from the drop down, look for 1032. The end condition is going to be through all. I'll click on my positions here, select this as being the face, select that as the hole, and the direction is the way I want it to be. It's going to go all the way through, and I'll say OK. And that gets me my tapped hole that goes all the way through the part. Okay, so those were 3 different examples of using the HoleWizard on one single piece, and I think that gives you enough that you should have a good idea of how to utilize this tool.